We're now going to look at solving problems which can be modelled as quadratic equations. So problems such as this first example here, where we're given this rectangle and the dimensions are algebraic, so x plus 3 centimetres for the length here and x minus 4 centimetres for this breadth. It tells me in the question the area of the rectangle shown is 44 square centimetres. So what I want to do here is start to think about how can I connect those things together? How can I connect the area of a rectangle with its length and its breadth? And we should know a formula to do that. So the formula I'm thinking of is area is equal to length times breadth. If I then start to fill in that formula with all the things that I do know, I'll end up with an equation which I can then go on and solve. So the area here is 44 square centimetres and the length is x plus 3. And the breadth that we're multiplying by is x minus 4. Remember, we don't need the multiplication symbol multiplying two brackets. What I can then do is start to multiply out these two brackets. So we end up with here x squared minus 4x plus 3x minus 12. And that's still equal to 44. If you look at that line there, what we have here is a quadratic equation. Now, again, it's not in standard quadratic form, so before I start to solve this, I'm definitely going to need to rearrange this, put it in standard quadratic form, make sure it's set equal to 0. So we'll begin to do that now. So what we can do here is, we'll start with this right hand side, x squared minus x minus 12 is 44. And then we want to bring that 44 across as well, so x squared minus x minus 56, and that's equal to 0. And we'll just swap the sides around there, so our 0 is over the other side. Now, when I come to solve this quadratic equation, I can do it by factorising, or I could do it by using quadratic formula. Factorising is pretty much always going to be easier and quicker, and unless the question's asking for decimal places or significant figures, it probably means it can be factorised, although you'll see later on in the course how we can determine that, whether a quadratic can be factorised or not. So x and x, we're looking here for a factor pair of 56 with a difference of 1, so it's 7 and 8. And we're looking for a target of negative x, so negative 8 plus 7 will give me negative 1 for our negative 1x. Now, breaking that into two separate equations as we do with quadratic equations, so x plus 7 equals 0, or x minus 8 equals 0, so x equals negative 7, or x equals 8. Now, as is always the case with quadratic equations, we have two solutions. What we're looking at here, though, is a practical real-life problem. So, if I look at those two possible answers, negative 7 and 8, you can quickly discount one of them. The negative 7 here is not possible. For instance, if I was to substitute this negative 7 into this expression here, x minus 4, then it would mean the length of this side would end up being negative 11, which is clearly impossible. We can't have a negative length. So what I can do is I can go down to the bottom here and just score out that answer. Okay, and just maybe a justification underneath. Cannot have negative length. Okay, so x equals 8 is my solution to the quadratic equation, but I need to go back and make sure I answered the question properly. Questions in context, remember, quite often we have to answer them in context as well. So looking up at the question here, it does say find the dimensions of the rectangle, not just find the value of x. So if x equals 8, then the length, which is this one here, is 8 plus 3. So I can write that down here. Length equals, and it's 8 plus 3, so 11 centimetres, and breadth. And again, looking up at the breadth of the rectangle here, x minus 4. Now if x is equal to 8, then that's 8 take away 4, which is 4 centimetres long. So I'm just going to write that down here. And that's it. We'll now move on to a slightly harder example. The reason this example can sometimes be thought of as slightly harder is because x is not given anywhere in this question. So we've got Robin is 3 years younger than Ian The product of their ages is 88. How old are the boys? Now, a couple of things. Quite often we forget the word product here. Product means the result of multiplication. So the product of 5 and 6 is 30. The product of 2 and 3 is 6, and so on. Okay, so basically in the last example with the rectangle, the dimensions had x in them. So we had something to work with. In this case, x is not mentioned. So the first thing we're going to need to do is define what x actually is. Now it's entirely up to you. You've got two people there. We're going to try and work with their ages. So I would just start by saying let x equal, and it can be either Ian's age or Robin's age. So I'm just going to start by saying let x equal Ian's age in years. If I know x is representing Ian's age, then that implies that Robin's age is going to be, well, he's 3 years younger than Ian. So if Ian is x, then Robin's age is x, take away 3. Now, if the product of their ages is 88, that means when I multiply Ian's age and Robin's age together, I get 88. So let's start by saying, well, if I multiply Ian's age, which is x, by Robin's age, which is x minus 3. Remember, if I'm multiplying, we need the brackets here. And the product of their ages is 88. And again, this is going to give us a quadratic equation. So that's the first two steps from over here done. We've defined what x is. And again, I could have made x equal to Robin's age. And then Ian's age would be x plus 3. In other words, 3 years older than Robin. Secondly, we form an equation using the information here. The product of their ages is 88, so multiplying the two ages together gives us 88. And then steps 3 and 4 are just to rearrange into standard quadratic form and then solve the equation. So we'll go through that step by step, multiplying out the bracket first. X squared minus 3x equals 88. Rearrange into standard quadratic form, so our x squared term, our x term, and we're bringing our constant term across, so subtracting 88 from both sides and setting that equal to 0. We then need to factorise to solve this quadratic equation. So we're looking for here a factor pair of 88 with a difference of 3. So that's 8 times 11 is 88, and they're 3 apart. And my target here is negative 3x. So I want to make negative 3 from 8 and 11. So negative 11 plus 8, or positive 8 take away 11. I'll put my x's in here. Again, quadratic equations, we're going to split into two parts. X plus 8 equals 0, or x minus 11 equals 0, meaning x equals negative 8, or x equals 11. Now, as is the case with the question we did previously, this question has a context. So, remember, x we defined to be Ian's age in years. Now, it's not possible for Ian to be negative 8 years old. You can't have a negative age, and therefore this must be the solution. So what we can do is, again, we can just discount the solution, and just, again, a wee justification is usually a good idea. So cannot have negative age, and therefore x equals 11. Now, again, it's not asking me to find x. The question didn't even mention x. The question is actually asking for how old are the boys. So a question in context like that should be answered in context. So Ian is, now Ian we defined as x. So x was Ian's age. So x is 11. So Ian is 11 years old. And we don't even need the algebra for the next part. We know Robin is 3 years younger. So Robin is 8 years old. And that's that question done.